Well, good morning, everybody. I'm going to start in the Pacific Northwest with just another look at yesterday's cloud field as the stream of moisture came off the Pacific and just continued to deliver a tremendous amount of moisture into the Northwest. In fact, if you look back over the last 7 days, we do have parts of coastal Washington and Oregon here that have gone off my color bar, which goes up to 10 inches. Now, the product I show you here is a combination of rain gauge and radar. And the estimates in parts of coastal Washington and Oregon are just incredibly high. Same thing for parts of northern Idaho. Now, overall, as we look at what this has done, there's been a lot of flooding throughout numerous regions here in the Northwest, and that's why we continue to see the flood watches and flood warnings posted throughout this area. Now, a lot of what you have over here across the east has happened. This was last week, so we've talked extensively about this, but this has been a lot that's been added just as of late. We still have flood watches that line from northern California all the way up to like Seattle area, and each of these little polygons in here with this brighter shade of color, that represents where we have the flood warnings now. There are a few areas of winter weather advisory, some strong winds we're expecting out of this as well, and we're going to just now look at some of the evolution of this pattern as we move forward, because not only here in North America, but in South America, we saw some pretty substantial model trends over the last 24 hours that we just really ought to talk quite a bit about. So let's kind of get into what we know about the near term. We're going to pick up with the high-res NAM model. And after some showers and snow showers here, including some graupel, I saw some graupel reports in the mountains of North Carolina and Tennessee. We're going to continue to watch some snow showers move through this part of the eastern Great Lakes out of Ontario today as we play through this evening, and then get into tomorrow morning some light snow in parts of New England. Now that's kind of the smaller of the two systems we're watching. If we come back here, you see that frontal boundary this morning continues to lash the northwest as we saw the snow level start to come down, so we start to pick up some more snow in the Cascades, some in the northern ranges here in California as well. As we play this into tonight and then play out there to tomorrow morning, early on Thursday, snow spreads through the northern Rockies and parts of Idaho. Could be some rain in the Snake River Valley. But it's what happens to this wave as it comes into Montana out of Alberta and Saskatchewan that I want to watch carefully. And what we've been seeing here is that the track has shifted a bit farther to the south, such that by Thursday night, getting into early Friday morning, this is a low that's now curling up over southern Manitoba. And the high-res NAM has continued to show a better kind of look on the back side of this at bringing in some snow into parts of North Dakota out of the Canadian Prairie. Same thing for parts of eastern Montana. Now we're going to look at several different model runs here in a few moments, but I want to tell you the evolution of this low with respect to the deeper wave that's to the south of it is what's really changing the pattern considerably. And that pattern is beginning today right here. So this is what we're keeping an eye on. All right, that wave, this little shot in the jet stream here, is what's ultimately going to be creating these two separate systems that are going to be coming out through much of the central part of North America. In the meantime, okay, there's still the strong onshore flow coming into the Pacific Northwest, but there's a big ridge sitting here. And therefore, we're going to watch a lot of heat just pour through the plains into the Midwest as we just progress through the next 3 to 4 days. That'll all be replaced, but there's quite a bit of just very warm air right now. And again, we kind of come back to this point that we keep seeing these incredible troughs coming off the East Coast, but they're too far east. We don't have the right setup in the North Atlantic to shove all of this back to the west, cause it to retrograde with time. Instead, these waves just eject, and they take all of their great upper level dynamics with them out to the open ocean. So what do we end up getting out of this next system? So we've seen the one that comes to the northwest. We've now seen the lead wave get here into southern Manitoba and then move toward Ontario. That's the snowmaker that could possibly happen later this week in North Dakota. The wave that follows it has the risk of severe storms to the south. And so this would be the new Day 3 outlook, valid on the 8th of December. We have a marginal risk over a larger area here in parts of the southern plains getting to the mid-south. And then the Storm Prediction Center on their Day 4 outlook has now identified this area from eastern Texas almost to Memphis, right into this area that has a risk then. But the evolution of the model's handling of this, again, this right here, has changed a lot in this forecast. And I want to show you what it looks like by showing you a forecast trend map. Now I'm doing this with the GFS, and it comes in tropical tidbits. I need to write my own code to do this so I can look at the European, I can look at all the models together. But I just went back over the last 8 model runs, and we put together a forecast from each of those runs, all valid midnight on Sunday morning. And what you're watching here is the change in the position. So if we let this start over here, let's let it get to the very end of the animation, There we go. Now here's the start over. So look, there was a westward retrograde, and then it just opens up the wave and shoves it much farther to the north. So here it is again. That's the end run right there. So I can't stop it. It's an animated GIF, but I need you to see that the whole pattern's evolved to take largely some of the bigger snows that we were expecting in the Midwest out of the picture. I mean, just completely out. And for some, that's going to be a good thing. For others, they're going to be disappointed not to get some of this snow. I have a wide variety of people that watch this, and a lot of folks that still have a lot of work to be doing in this area, field work. They don't want this heavy precip or the snow to come in and shut things down. And then again, I got a lot of you that watch this that would love to see some snow. And this has really shoved all that snow in a different direction. In fact, the wave is going to wait to amplify until it gets over the northeast, where the biggest snows will likely be out of this system. So that was the GFS. This is the newest European model. I had shown you runs valid for this time in the last 3 days that put down massive snow in Indiana, Ohio, Michigan, up in Ontario. You saw one that hit Illinois, Wisconsin. You saw one that hit Kansas, Nebraska, Iowa, Missouri, Wisconsin. I mean, all of that. And this is what the newest run looks like. The most consistent part has been actually the Northwest, where we typically see the least consistency in the forecast, which is the Northwest. So I'm going to show you the dual model run of this in a few moments, but I want to get out kind of the big idea here. Newest European model run, looking at total snowfall through the next 7 days, now looks something like that. And remember, this was an area in through here where we had seen so much more. We now see that the European model settled better in on that northern track, so heavy snow is coming out of Saskatchewan into Manitoba, but this does clip North Dakota. And then New England likely gets hit pretty hard out of this. There's better snows in the Rockies and the Cascades once the more colder air gets in place. But this is the European model solution. That's the GFS. So both models making a substantial change in the precipitation type, intensity, and timing for this system in the midsection of the United States. And I want to tell you why, what's going on here. So I'm going to take you back and show you the jet stream flow now. So remember, we're keeping an eye on this wave here. There's the large ridge that's going to make things quite warm, and the jet streak that's just too far east to do anything for the East Coast right now. Well, as we play this forward, your lead wave is sneaking right up here. This is Friday evening. So on the nose of that jet streak right here, and you can see there's a little bit of a curve in the flow. We're going to build the low that goes across Manitoba and ends up over the Hudson Bay. Now, normally, if I were looking Friday night and I saw this, that's another jet streak, trying to make its way to the base of a trough, and the trough is either neutrally tilted or maybe a little bit positively tilted, I'd be saying, bring it on. I mean, that's going to be a wave that comes right over the mountains and then just ejects and does so in an impressive way. But this is now 12 a.m. Saturday morning into Saturday midday and then Saturday afternoon. And we have a problem here. There's a jet streak that starts to extend down range of the trough axis. And the jet streak that was on the back side doesn't extend. And if you watch right here at the base of the trough, this is where the problem is going to be. As I take one more step forward, that is now where our slowest winds are. Now, dynamically, this happens. We tend to get our fastest winds through ridges and our slowest winds through the trough. That comes back to just the fundamental, we call it the quasi-geostrophic equation. It just tells us how the winds flow through the jet stream. But we can break that with tight temperature gradients, which we don't have, by sending little jet streaks through the base of the trough. So your most ideal situation for blowing up a huge system is to get something like this right here. You end up getting what's called the curvature effect. That would be this, combined with the jet streak effect, which would have been there to give us just a massive amount of upper level divergence sitting here. As it stands, we have curves, but the jet streak's in the wrong position, actually working against the low developing. So long story short, I love everything about this trough except for its speed. It's missing the piece rounding the base of the trough. And that is opening up a large wave rather than tightening up a deep low right here in the exit region. Well, let me rephrase it. Right here in this divergent quadrant of the trough's curvature. So what this does is we have to wait till later. And you notice that by Sunday evening, getting into early Monday morning, we start to get those pieces. There's the curve. Now we have this extended part of the jet streak making it into the base of the trough. So what's going on here? Do you see how the winds have now maintained their speed? Look at the difference, okay? Here they stopped, didn't stop, but they slowed down considerably. That is a convergent pattern, not divergent, convergent. And then if you get over here, then it comes through, the trough takes a big negative tilt. This, by the way, when I say negative tilt, it looks like a backslash rather than a forward slash. And that's just going to kick off a big low here. That's what happened. That's what's changed. And by the way, it's going to change again because this wave is still offshore. We haven't yet sampled it with our weather stations, weather balloons, anything. It's way offshore. We're just getting satellite estimates of it. That's really what's going into this. And what that's done is this. Let me take you back. I was jumping a little ahead here. So we've already played through Wednesday into Thursday. So you can see, look what the models are doing here. This is Friday morning. The low here in in Manitoba, GFS bringing some snow down. So is the European, but it's a little bit farther to the north. Maybe some cold rain to start off. There's the snow coming in the European. This is going to be Friday night, so that's the northern plains. Now remember, this is the low that has the better support initially, and it's going in this direction. So here it is. It's out there in the European. It's the second wave that we're missing now. So take a look. That was just quickly through 6 a.m. Saturday into noon on Saturday. And remember, the last time we saw this model was tossing snow down. The European was tossing some snow down, and now it's a big open wave. It's just wide open, and it doesn't curl up. Now watch, until we get the jet streak on the backside to sneak in there and support the development of this low over New England. Now the two models are different in their position. You can see the GFS more progressive. It's got it through further. The European is slower. That's a very common difference between these two models. But this could be producing some big inland snows in New England. We'll have to go take a look at those values in just a few seconds. Now, on the other side of this, remember, getting into Friday night, then again Saturday night right here, we're going to have to watch the risk of these strong to severe storms in the southern plains. That's day 3 and day 4 in the forecast. And that could possibly progress farther to the east. Several of these models are putting down extremely heavy rains over parts of the southeast with a quick-moving system here. And note, the European wants to put some Appalachian Mountain snow in here as well. Now, that's not to ignore what's still coming in the northwest, because here we are this Sunday into Monday, and we still have more flow coming into the northwest as we go forward. What's after this, we're going to have to wait and see. Both models are trying out there around the 13th, 14th, 15th to build something in the southern plains. So that's your kind of latest multi-model analysis on how things have shifted. So here's what you end up getting. Here's the new 7-day forecast from the European model on total precipitation. Look at all three pieces, 1, 2, and 3. Here is the GFS solution. They're not that dissimilar now. So what we have to do is we have to start looking at some probability maps. Who's wettest? This is the chance at getting at least an inch of liquid out of the next 10 days. And then you can go this up to 2 inches to see the really heavy precip in the northwest. And we'll take it up to 4, and that's really going to be the only area. On the drier side of this is to be total QPF under 0.5. I mean, much of the plains, the southwest, that story's been going on for a while. Now, what about the snow side of it? Let's take a look at 3 different regions using the high-res European as our guide. The northwest first. So through Thursday into Friday, we're going to be picking up some more snow, but we've got to get the snow levels down. They're going to start to do that toward the end of this week. So we start to see better snows in the Cascades, a little bit in the northern Sierra Nevada mountains, and then in the Rockies here. But then watch as we get into the weekend. That's what's added up on Saturday into Sunday. And you're going to see here as we play this out to a full 10-day, we'll wait late in the forecast time period to see if something can brew down here in this part of the southern plains. But overall, next 10 days, Cascades stand to pick up another 15 to 25 inches. Parts of the northern Rockies could pick up well over a foot as well. Let's go from here into the Midwest, and this is now where the changes have been pretty substantial. This is getting into Saturday and Sunday. Now look, that's your swath of snow that's left. Not a whole lot. We'll talk about the Northeast in a few seconds. Overall, 1 to 2 inches is possible in North Dakota. And then again, we'll watch late in the time period for something to sneak out down here in the southern plains. I'll just have to be patient and kind of wait to see how that next wave evolves. But New England, as I mentioned, I think is the hot spot here. So as you watch, this is now Sunday morning, getting into Sunday evening, Monday morning. And we have the potential here to really add up quite a bit of snow. Maybe a good 4 to 8 inches of snow across a big section here of New England. Where that rain snow line is going to be will be challenging. We have to wait to see how the low curls up, but that's the latest we've got. To just kind of put one more piece on this was the probability of getting at least 3 inches of snow in the next 10 days. So if we go down to 1, might as well do that. There's the probability of 1 inch of snow in the next 10 days. Here's the chances for 3. Now we can just keep stepping this up to 6 and 12 just to kind of get an idea on who's going to get the heaviest snows. But with a lack of really good cold air, it's hard to put much more snow down than what we're seeing here. Where's the pattern go after that? By the 16th of December, you still got the same issue. I don't want that. That's what's going to give us a drier signal northwest flow. But the pattern in the model seems to open up and keep progressing. So by the 17th of December, getting out here to the 19th, there are a couple of things I like seeing. Now, if I'm up the East Coast, I want this. Put a big ridge here. Start to build those heights. It would be great if we could do the same thing over Alaska, but these two things are not playing. Notice we have a trough over Alaska and a ridge building in the North Atlantic. And you say, why do you like this? I said, well, what happens every time we get this is a better chance of getting a system to curl and run up the East Coast, which we need to bring that moisture to the East Coast. We need to get an early winter season going here. So we'll watch the evolution of this North Atlantic pattern going forward. But right now, if we look out there at week 2, the models are, well, the CPC's drier north, the Europeans drier west and Midwest and north. And you can see the same thing in the GFS ensemble. The models are hinting at something developing in the southern plains a week from now, about 9 days from now, excuse me. So we'll keep an eye out on that as the forecast evolves. On the temperature side of it, we've been talking about this all week, the heat that's coming into the plains. I'm heading to Sioux Falls this afternoon. Like I said yesterday, I'm not going to bring a jacket. It's going to be so warm while I'm there Wednesday to Thursday. And that heat's going to follow me home. I have a very warm day here on Friday. Getting into Saturday and Sunday, that heat presses into New England. Now, this is the time period when that low begins to take shape. But just notice these temperatures here. Because that wave no longer digs, we've just opened things up to a bit more mild air than what it was originally forecast. And we don't see a connection to truly cold air like Arctic air for a while. Latest frost map, again, we're going to watch out for some pretty cold temperatures in the southeast and the Central Valley of California. I'd like to show you some of the timing on that. This is Thursday morning's lows, pretty chilly down here in the southeast. Same thing on Friday morning as well. And then as we go from Friday into Saturday and that warmth spreads east, we're going to see the colder temperatures sneak into California's Central Valley. So we have another chance at a frost event in the Central Valley, probably on Saturday morning and again on Sunday morning. But overall, these temperatures, I kind of talked about it yesterday. Remember, all that cold air is in Russia. So we play out over the next 15 days. And while cooler conditions start to build, and we've seen a bit of a cooler trend in the model, here, this is, it's important to see that this particular pattern is cooler south without a connection to deep Arctic air. This is just subtropical jet stream flowing over the top of this cloud cover, hopefully some better precipitation. And what you're seeing here. By the way, this is a very El Nino look to the pattern. A very El Nino look to the pattern. So is El Nino controlling some other things? Well, we need to get the MJO out of phases 4 and 5 and have it sweep around here to phase 7, 8, and 1. And if that does occur, you'll get an even more El Nino flavor to the pattern as we approach the peak of this El Nino. It may have peaked already, but possibly another few weeks, and we'll see how that all evolves. Now, we have some new long-range data to talk about as well here in a few moments. But first, what I'd like to do is show you a week's worth of precipitation here as measured by satellite. And we're going to focus in on South America. Now, you watch. There has been convection in the atmosphere that's been producing rain across a big section of Brazil. We've been worried about being very dry. So if I play that for you again, you're just taking note that there is daily convection in this area of Brazil. So there have been places that have been getting the rain they've needed. You can also notice coming out of Argentina to southern Brazil, Paraguay, Uruguay, extremely wet conditions down here. I'll move the mouse so you can see this again without me floating over the top of it. Now, my point behind telling you about what's happening in South America is that the forecast trends there, just like I showed you for North America, have changed considerably. We need to just make sure we assess what that change means. So let's go have a look at it here. So my next map looks at the chance over the next 10 days of getting at least an inch of rainfall. And this is from the European model. Now, what's important is over a 10-day time period, it would be quite common to get 2.5 inches of rain during the month of December in north central Brazil. So when we see the probabilities here in the 50 to 80% range, higher as you get into the Amazon, this is still concerning. We need better probabilities of getting heavier rains. In fact, 2 inches would be about normal. And whoops, sorry, I got a new model running there. Let's go back to the 0Z. Sorry about that. There is your kind of 10-day outlook. Now, these values are low. We would expect more, but it's not to say that it is dry. We have to be very careful with the language. It's drier, but not dry. So there is storms still coming in here, and we have questions if that's going to be enough to support the crop. So what has changed? Well, the European model has trended drier here. It's trying to bring better rains into parts of Mato Grosso. And remember, Mato Grosso is about 25 to 30, maybe 33% of the total production of both corn and soybeans. When you see it dry in this area, I just want to make note here. It's not as though there's not agriculture in Para or in Rondônia, but this is the Amazon. This is not, this is a small fraction of where crops are grown. Most of it is in the southern half of Mato Grosso into Mato Grosso do Sul and then down through this area here. So I just need you to note that when you see dryness in this area, this is not alarming for cropland, all right? But this is a major trend toward the drier side of things. We're still very wet, Paraguay, over to Rio Grande do Sul, Uruguay, and then the newest European wants to provide exactly what is needed in Argentina to break a long-standing drought issue. Okay, well, now what about the GFS? The GFS has still got a much more expansive dry area into Mato Grosso. Now just remember, outside of that circle I drew, especially to the north of it, and even over into Tocantins, these are not productive ag regions. There is ag in there, but if you just do a comparison, between there and south central and central Mato Grosso to Goiás and Tocantins, or Mato Grosso do Sul, that's a big area for growing crops. So remember, this northern extent, don't fear it for hurting ag. But just like the European model, wet in southern Brazil, Paraguay, Uruguay, and better rains for a big section of Argentina. So where's the trend? What did I want to mention to you? The problem has been kind of in the European model over predicting rains, I think, at times, and going much drier here. The GFS has been pretty consistent. It just doesn't want to give rain at all. So we'll just keep an eye on the evolution of that, remembering that there is still rain even though you see drier conditions. So we have to wait to see the evolution of what happens out of South America. The last thing I want to cover today is a bit on the new long-range forecast. We're going to do this a couple times this week. This is a bit more evidence that El Nino is at its peak. So at some point here in December, it's expected to reach its peak, and then we're going to be going down in terms of the strength of this El Nino. It'll still influence the things through January, February, March, April, and probably into May. But possibly by the time we get into next June, July, August, we'll be talking about neutral conditions and maybe a turn back over to, maybe La Nina. Now watch. Here's ocean temperatures in December into January. There's a bit of a fade here going into February and March and April. And what we start to see is a return toward normal ocean temperatures, maybe even cooler by June. Now the North Pacific stays warm. That's going to be a key part of this pattern as well. But that evolution right there is going to be what we need to keep an eye on. Now what did that do overall to the new forecasts? Well, let's just go have a look at them today. We'll talk about them in more depth with each forecast the rest of this week. This is a seasonal forecast graphic. Whoops, I'm way ahead of myself here. Back for December, January, February. So they increased precip in the Northwest. I'm like, well, of course it did, because the model was just initialized very wet here. Remember, typical El Niños are drier in the Northwest. They kept the wetter conditions through most of California. They've expanded this area that's been things forecast a bit drier for December, January, February, but wet still in the south. And it seems to be an active secondary storm track coming out of the plains, through the eastern Great Lakes. So I got to watch that carefully. We then go into January, February, March. Let's go out this whole time period here. Then this is February, March, April. This would be March, April, May. This would be April, May, June. So this is a good 7-month forecast. And I'm going to explain to you this time period and beyond in just a few moments. What about South America? Since we just looked at the precip there, let's go to South America and come back to the near term. Now we know that the models have tried to trend wetter north late December. We've talked about that a lot. So wetter trend later in December, not now, but later. We then see that as we go out here to December, let's try that again, January, February, March, they're trying to make it drier in the central part where it's been wet. And we go into February, March, April. And I'll just make a point here. If that verifies, a lot of the talk about the really dry conditions here now is going to go away. We'll have to start worrying then about, is it going to be too wet during harvest for this crop in this area? It stays wet south. That's a very strong El Nino signal. Same thing for parts of Argentina too. We just take this out to March, April, May. Here's May, June, or April, May, June, and this is something we got to talk about. Did you notice how dry the models got in this area? Drier in that area, April, May, June. We know this safrinha crop's going to get planted late. We know the delays in the Cerrado, which means if we dry out the monsoon faster than normal, this is a problem. So we'll investigate the temperature pattern on this. We've discussed for North America, right, let's go back to North America here, that the temperature pattern will likely be a back half loaded cold go of it. So we'll just wait to see if January, February, March is in fact trending a bit colder in this area. But I think I'm just going to stop there. Well, let me give you one more thing. I showed you this a second ago. Sorry, I'm kind of carrying on a bit this morning. But I showed you a second ago that we may be talking about, La Nina emerging here. Years following an El Nino that peaks in winter look like this June to September. So that was the last thing I wanted to share with you. So this is precipitation anomalies. You can see where it was wetter and drier in southern plains and drier in parts of the southeast, getting up toward the Tennessee Valley. So that's something to be on the lookout for. We'll talk more about that over the coming months. Okay, I really appreciate you hanging on a long time this morning. Just had a lot to discuss with the model trends and some new long-range data, but we'll stop it here, and we'll talk again soon. Thanks.